Okay, hi folks, welcome back. Today we're going to do one quick topic, and then you'll have the period to work on practicing your work with trigonometry, and those that need to make up the test can do that. Before we do that, I want to just kind of make sure we're clear about what we've done so far. So look up on the screen there, and I want you to tell me what I should write here, a hypothesis, and what I should write here as the conclusion to describe what types of problems we're able to solve now. If I'm given certain information, then I can find certain information. What types of problems have we been working with? What information did we have? It had to do triangles, right? Was it any kinds of triangles we're working with? Right triangles, good. And what other information were we given in those right triangles? Please put your phones away. We were given two sides? Is that what we were given? One side of an angle, right? We were given something like 37 degrees for the angle, and we're given something like an unknown side here, but a known side here. Do you agree? So we're given one acute angle in addition to the right angle, one known side. And what were we able to then find? Missing side or missing sides? We could find y, couldn't we? And we could find x. So today, we're taking it one step further. You remember last class, problem number 4, you were unable to do. Why was that? How was number 4 different? You had to find the angle. And to do that, we have to be given two sides, right? Something like this. And what I'm going to tell you today is that the geometry is actually exactly the same as what we've done in the past. It's just the algebra that has to change. So let's set this problem up like the geometry we've done in the past units. We focus our eyeball on the angle. This time it's an unknown angle. And relative to that, we claim whether these lengths are opposite, adjacent, or hypotenuse. What do we call the 5? Hypotenuse. What do we call the 3? Opposite. It's not adjacent because it's not touching the angle we're talking about, right? It's on the opposite side of the triangle. Therefore, since we're dealing with O and H, we call into play that thing that is so katoa. And in this case, if we have O and H, what goes in front here? S. That triggers for us that we're going to be using the sine function. And we know always, always, always after the sine comes what component? The angle. So in this case, that would be X equals what over what? Opposite over hypotenuse. It goes in order. So the opposite would be 3. The hypotenuse would be 5. Now, that's the geometry, creating the equation. Now we have to solve that equation, and that's the algebra. And this is a little bit different. This is what you didn't know how to do on problem number 4. But let me take us off on a little tangent for a second. Thank you for the courtesy laugh. All right, if I had x plus 3 equals 8, how would you solve that? Subtract 3, because you'd say, I want to get x by itself. Right now, it's got an additional plus 3. So I do the opposite. I do a minus 3. If I do it to one side, I do it to both sides, and I get x equals 5. What if instead it were a problem like 2x equals 10? You divide by 2, because right now it's being multiplied by 2. You have to do the opposite, and division is the opposite of multiplication. Do it to both sides, you get x equals 5. What if I had, for example, something like x squared equals 25? You'd square root. Because x is being squared, you have to do the opposite of that. When you introduce the square root, we really should say x equals plus or minus 5. Regardless of what's going on, we figure out what's being done to x, and then we undo it. The same applies here. What's being done to x? It's being signed. Sine is an operation. It's like that magical wand that lets you say, tell me an angle, I can magically wand it and tell you the ratio of two sides. So if we want to undo this, what we need to do is unsign this stuff. And there's a function called inverse sine. In other words, if I take the inverse sine of the left, I then have to take the inverse sine of the right. What do you expect happens if I take the inverse sine of x? It cancels out, right? Leaving just x. And what we're then left with is the inverse sine of 3/5. And that is the solution in precise terms. I do require that you write that into our problems as you're going through them. Don't just jump to a calculator solution. What this says is, what angle gives me a ratio of 3:5? And we'll then use our calculators to do that. And just as is true for so many of the functions on a calculator, the little yellow things tell us what the inverse function is. Like instead of squared, you could do second squared and it would give you square root. Similarly, if you want to find the inverse sine, you're going to press second, then sine. But before we do that, let's make sure our calculator is set correctly. How do we check it? Sine of 30 equals, what do we expect it to be? 0.5. It is. Excuse me. Excuse me. So in this case, we want to do the inverse sine of 3/5. So I'm going to take my calculator. I'm going to press the second button, followed by the sine button. You'll notice that now my sine has a little -1 exponent on it, indicating it's an inverse. And then I'll do the fraction of 3/5 by just doing 3 divided by 5. And I'll hit enter. It's really hard to see there. And what I end up with is x is equal to approximately 36.87 to round to the nearest hundredth. Any questions on the process? And now we'll go through one together. Okay, let's take a look at our work for today. So let's set up the geometry of the first one here. So, Katoa, thank you. Which one is it? Yep. That calls for a sine. So always, always, always after the trig function comes which part? The angle. So in this case, it would be x equals the ratio of opposite over hypotenuse. So 15/24. That's the end of my geometry. Now I need to do the algebra. I want to solve for x. What's being done to x right now? Careful. It's not being multiplied by sine, because that would suggest we should divide. Sine is a verb. It's being actively signed. Therefore, we have to undo it, not by dividing, but by taking the inverse sine, because that's the opposite function. That gives us x equals the inverse sine of 15/24. Again, I do require you to write this in your answers. Bless you. And then use your calculator to take the decimal approximation of that. Everybody use your calculator. Please make sure that when you do inverse sine of 15/24, you get the same answer I do, which is 38.7. round to the nearest tenth, so 0.7. Let's put a degree symbol on it. Any questions on this? Please try number 2 yourselves now.
Oh, Mr.
Uh-huh.
Why are you using the wavy equal sign for the regular one?
Because an equal sign means it's the exact same value, it's precise. A wavy one tells me that I'm taking the approximation, I've rounded this number. So it's not quite that.
Oh, so like if this rounded.
Yeah. Again, you guys do number 2, please. Okay, take a look at your answers, see if you got a 43.3 degrees as an answer. 5, I got that. 3, I see a little mistake, I could have gotten that. 1, I didn't get that, I don't know why. You can't make me get it. Good.
43.34.
Yep. Okay, on the 3rd page of this document, you'll find a nice little summary. It's got 4 questions asking you to find the missing sides with trigonometry and 4 questions asking you to find the missing angles with trigonometry. I'd like you to treat that as like a little mini practice quiz. In other words, get help, work with people, be collaborative all the way through this process today. But when you get to that page, I want you to do it totally independently and see if you get the right answers to help self-assess your understanding. What you see I posted right now is the answers to those. The first 4, the sides ones are up here, but they're mixed up in the order. And these are the angle ones, they're mixed up in the order. So you'll have to find which one is the right one. But if you didn't get these answers, that means you've done something wrong. Go back, look at it, ask me for help if you wish. Okay, you've got the rest of the period. If you need to take a retake on the last unit test, today's a good day for that as well. You've got the period.